Today I want to talk about motor cage geometries in a 4 flywheel rapid strike setup. Now this is a work in progress. This is a rapid strike that I'm currently working on. It's a Raven integration. And I wanted to stop and take a moment here to talk about the geometries of the cages themselves. Now this rapid strike has the same motor setup as the Mark II. It's got the Kaizen 16180s as the first stage, and it's got Rhinos as the second stage. All of that running on 4S LiPo for the testing that I've done with this. The only difference here between this and the Mark II and the Mark I previous is the distance between the motor cages. Now, for the Mark I, the first one that I did, the motor cages were as close together as I could possibly get them. I crammed them right up against each other. And when I upgraded that one to have this motor configuration, the 16180s and the Rhinos, I ended up getting about 140 feet per second out of the blaster on average shots. Now the Mark II, I took the cage and I took this piece right here and shaved it off on the motor cage. And so the motor cages were farther apart than the Mark I, but still not as far apart as this one. And with that configuration, same motors, same power source, I was getting about 155 feet per second. This one I took and I moved the motor cages even farther apart so that the two lips are effectively touching each other on that distance. And with this motor configuration, I'm getting about 165 feet per second. So it's about a 10 to 12 FPS increase just by moving the motor cages apart. Again, it's got the exact same motors, the 16180s, the Rhinos, and it's running off of the exact same battery setup, the 4S LiPo that I was doing the testing. But just by spacing the motor cages out, I was getting another 12 feet per second in performance. Now, if we take a look at the cage itself, and with an Elite dart, you'll kind of see what's going on here. As the dart's coming through, when it hits the midpoint, the back of the dart is still in contact with the first stage, and the front of the dart is coming into contact with the second stage. And at that point in time, you've got all 4 flywheels here. Now, by spacing them apart, you increase the amount of time in which the dart is in contact with a set of flywheels as it's going through. That increased time allows the flywheels to impart more energy into the dart, and therefore you get a higher FPS. You get a higher velocity coming out the other end. Now, the reason I think this to be the optimal setup for this 4 flywheel is if you look at the midpoint of the dart's travel through the cage, it's in contact with all 4 flywheels for a very short period of time. And that serves to stabilize the dart as it's coming through. So as you're at that point where the 4 flywheels are touching it, the dart aligns properly and it comes through and maintains that contact. So you don't have bouncing off flywheels, you don't have fishtailing, you don't have darts going off crazy because you've got that point in time where the dart gets stabilized. So we've moved the flywheel cages far enough apart or farther enough apart to get more velocity imparted, longer time in contact with the flywheels, but we've left them close enough so that they maintain contact. All 4 flywheels are in contact with the dart at the midpoint that it's going through for stabilization. So those two, this is the reason why I believe this to be the optimal setup for the motor cages for this flywheel rapid strike. Questions, comments, leave them in the comment section below. And I'll also post a link down there to the chronograph readings that I've got when I tested this flywheel cage.